Okay, folks, this is the last of the recordings for workshop number 9 for Math 1211. It is here's the series, summation n equals 1 to infinity. And we have minus 1 to the n plus 1 times natural logarithm of n over root n. Taking a look at that, the suspicion is that if I remove the minus signs, I will get divergence. And I see that because we have natural logarithm of n over root n is greater than natural logarithm of n over n. And so we're using the comparison test, and summation n equals 1 to infinity, natural log n over n can be determined, whether that's convergent or not, can be determined by the integral test. So we're going to have the integral 1 to infinity, natural log x over x. And that is the limit as x, that is the limit as b approaches infinity. And I'm going to take the antiderivative in the same step here. We have 1/2 natural logarithm of x all squared from 1 to b. And we end up with infinity here, because the upper limit is natural logarithm of b squared. B goes to infinity, that's infinite. So therefore, summation natural log n over root n is also divergent, comparing that to summation natural log n over n. So this series is not absolutely convergent, but it is conditionally convergent because we have, so using the alternating series test, just refresh your memory about that, we have the limit as n goes to infinity of natural log of n over n to the 1/2. That is the limit, using L'Hopital's rule, of 1 over n, 1/2, n to the minus 1/2. That is the limit as n goes to infinity of 2 over root n. That's 0. So we needed that. Also, this a sub n is a term that is decreasing, because if I let f of x equal natural logarithm of x over x to the 1/2, and I take its derivative, I will see that we have x on the bottom, that's x to the 1/2 squared, x to the 1/2 times 1 over x minus natural logarithm of x times 1/2 x to the minus 1/2. Simplifying that, we get an x to the minus 1/2 coming out. We have a 1 minus natural logarithm of x. And that is negative whenever natural log x is greater than 1, or for x greater than e. So the alternating series test can be applied, and applying that means that this series is convergent, and therefore it is conditional. So given series is conditionally convergent. Okay, so we are done that. That completes all the problems on that one. Hopefully this has been of some help for you. So I'll just finish off here.